Suppose this is a space. In this space, there is a one point. Let us say point of x comma y comma z. It is a three-dimensional point. If you express this point in terms of scalar, like f of x y z equals to x square y plus 2x square y square plus z square by some equation, without using I, j, k, without using I cap, j cap and k cap, without using these vectors. It is a plain scalar value. Then f of xyz is called as a scalar point function. And suppose f of x comma y comma z is expressed in terms of vectors, that is in terms of using I cap, j cap and k cap, and here is some function, let us say x square y plus x cube y plus z square xy, something like this, where we are using ijk. Ijk are the unit vectors along x direction, along y direction and along the z direction. Ijk are the unit vectors. So if you are expressing f of xyz in terms of a vector, if you change the value of xyz, the point even will change. So the point f of xyz is expressed in terms of vectors, then this point would be called as a vector point function. And without using ijk, it is a simply equation, simply algebraic equation, then f of xyz would be called as a scalar point function. So in vector differentiation, we specially utilize two words. One is a scalar point function, another is a vector point function. While talking about fluid dynamics or electric fields or electromagnetic fields or electromagnetism or magnetic fields, we specially talk about two kinds of fields. One is rotating field, another is a non-rotating field. Non-rotating field is also called irrotational field. Non-rotating field just move from one place to another place, as shown here. It is a field, but it is a non-rotating. And this is rotating field. So a vector field can be rotating field or non-rotating field. When the vector field is rotating or non-rotating, how to decide that? How to decide a given field is rotating or not? That we can decide with the help of a mathematical concept called curl. Curl of a vector help us to decide the nature of the vector. As I already told you that it may be either rotational or non-rotational. So curl of the vector help us to decide whether the given vector field is rotational or non-rotational. Second point, the curl measures tendency of a vector field to rotate at a point. So is it rotating or not rotating? That we can find out with the help of curl. And the third point, magnitude of the curl gives strength of circulation, or it gives the rotational strength of the vector field at a point. Let vector f, this is nothing but vector point function. And this is the nebula, is a differential operator. Then we have to find out the curl. So curl of f, the curl of f can be denoted like this. Curl of f is given by cross product of differential operator and vector point function, that is nebula cross f. This is equivalent to, it can be written in the determinant form, nebula cross f, that is nothing but curl f. So here is the I, j, k, I cap, j cap and k cap, and here dabba upon x, dabba upon dabba y and dabba upon dabba z. Sometimes it is also called as a dou upon dou x, dou upon dou y, dou upon dou z, also called as a dabba upon dabba x, dabba upon dabba y and dabba upon dabba z. And here is f1, f2 and f3. So this is the formula to find out the curl of f. And if the curl of result is 0, then we say vector f is irrotational. And if the curl value is not equal to 0, then we say vector f is rotational. Thus, by using curl of f, we can easily decide whether the given field is rotational or irrotational. Here is the example. Find curl of v if vector v equals to xi plus 2yzj minus 1 plus 2zk. Here is the solution. Comparing vector v with v1i plus v2j plus v3k, where ijk are unit vectors, I cap, j cap and k cap. Here as well as everywhere it is a cap only. Implies v1 equals to x and v2 equals to 2yz and v3 equals to minus 1 plus 2z. Now curl of v, vector v equals to nebula cross vector v, which is equals to determinant of I, j, k, dou upon dou x, dou upon dou y, dou upon dou z, dabba upon dabba x, dabba upon dabba y, dabba upon dabba z, and v1, v2, v3. This is equals to ijk as it is, dabba upon dabba x, that is dou upon dou x, dou upon dou y, dou upon dou z. Some people call it as a dabba and some people call it as a dou. I have the habit of dou here. For you, I am speaking both the one. One is the dabba, another is a dou x. That is a dabba upon dabba x, dabba upon dabba y, dabba upon dabba z. Otherwise, dou upon dou x, dou upon dou y, dou upon dou z. Now what is a v1? v1 is a x. What is v2? 2yz. And what is v3? Minus of 1 plus 2z. Now expanding determinant, we get, so we have the, for I, this and this, for the case number 1, so dou upon dou y, dabba upon dabba y of 1 minus of 1 plus 2z and dabba upon dabba z 2yz. Similarly for y and for z. So this is equals to I, and here is a 0 and here is a minus 2y minus j 0 minus 0 plus k 0 minus 0 is equals to minus 2yi, that is the I cap. Therefore, curl of v equals to minus 2yi cap.